Welcome. In this video, we're going to explore spread a bit more, and I gave you three sets of data, and let's go ahead and create dot plots for each on the provided number line. So I have a bunch of fives here. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my dot plot's going to be fairly boring. And there's my dot plot. The dot shouldn't be falling off the top there. There we are, that's better. Okay, so the second set of data, set B, is a little more interesting. So I have a 2, a 5, and go ahead and pause your video and continue this dot plot. All right, so this one should look like this. You have some values all the way at the very ends, whereas the first one, they're all stacked. Let's see what the third one looks like. Okay, so there's the third dot plot. And if you notice, it's actually very similar to the one above it. The biggest difference is instead of having two sevens, we only have one up here. Instead of having two twos, we only have 1, 2. And then this set C lacks a value of 0 and 15. So now let's consider this question here at the bottom. Without actually computing anything, make a guess as to which set of numbers has the largest standard deviation, range, and variance. Now, without getting into any technical definitions of these statistics, the standard deviation, the range, and the variance are all measures of spread. That is, these tell you how far spread out the data is. So looking at our sets, which set is most spread out? We want the largest of the measures of spread, and which data set is most spread out? Well, that would be set B here. It has a minimum of 0 and a maximum of 15. So the data here encompasses this entire visible number line, whereas this one is kind of squished in here, and set A is very squished in. All right, let's continue. So without computing anything, make a guess as to which set of numbers have the smallest standard deviation, range, and variance. Well, again, of all our sets, set A was the only one that was stacked up with all the values in one place. So set A has to have the smallest of these three statistics. Finally, I'm going to show you these last parts. So for part D, you're supposed to calculate the standard deviation, variance, and range for each set and explain if this confirms your responses to parts B and C. For those of you in my statistics course, this question will be on the quiz, so I'm not going to answer it for you. But after you're done with this video, you should answer question D, E, and F since you will be asked about these on this upcoming quiz. So make sure you compute the standard deviation, variance, and range for each set and describe whether or not this confirms your responses to parts B and C. Please look in our Canvas page to find the definition of resistant and tell me if any of these statistics. For E, please look up the definition of resistant on page 33 of your notes and tell me if the standard deviation, variance, and range are resistant or not resistant and explain why. And then I'm going to give you a clue for this one. Can these statistics ever be negative? And for the clue, let me begin with the range. I'm going to remind you that the range is the max minus the min. That's my clue. For variance, I'm going to remind you that it's computed in this manner. And so what to consider here is this square is my clue. And then finally, for the standard deviation, remember that's just the square root of variance. So those are the clues. Those of you in my stats course, pause the video and write out responses to all of these. It will be on the quiz.